This is Chapter 4, Lesson 5, Comparing Functions. Let's take a look, first of all, at our important point here. They talk about the fact that functions can be represented by a table, a graph, an equation, or words. You can compare two functions represented in different ways. This is just like we did in previous chapters, where in one case we've got a situation where they give us a speed in words and then they want us to compare it to a speed shown in a graph. And really all this amounts to is find a unit rate no matter what way they give it to you, whether they do it in a table, a graph, an equation, or words. Find the two unit rates and compare them that way. So let's take a look at example 1 and you'll understand exactly what I mean. You've done this before and this should be really easy to do. A zebra's main predator is a lion. Lions can run at a speed of 53 feet per second over short distances. The graph at the right shows the speed of a zebra. Compare their speeds. So we have a speed for the lion. The lion is 53 feet per second. So now we just want to figure out what the speed of a zebra is. So we can take these values here and do our change in y over change in x. And our change in y, remember it's always the x value then the y value, so from the first point to the second point, the change in y is 118 minus 59. Right here's where I'm getting these numbers from. 119 minus 59 over 2 minus 1. So we're going to get a unit rate right there, and 118 minus 59 is 59. So the zebra is 59 feet per second. So clearly the zebra can run slightly faster than the lion, so as long as it doesn't get surprised, it can get away. And right down here is that statement. Please press pause and do letter A. All right, let's take a look at example number 2 here. We have the function m equals 140h, where m is the miles traveled in h hours. It represents the speed of the first Japanese high-speed train. The speed of a high-speed train operating today in China is shown in the table. Assume the relationship between the two quantities is linear. So we have 140h. So in other words, this would be m equals 140h. This would be 140 miles per hour. And now we need to compare it to this train in China. So we can compare the functions y-intercepts and rates of change. The y-intercept for this function is obviously 0. So the y-intercept is 0. And like we said, this is our slope. So our m equals 140. Now we can take a look at the Chinese train, and we can subtract these values here, which they do for you down here, and recognize that we are adding 217 per cell. So for the Chinese train, we have an m, or a slope, of 217, and we could always subtract backwards and we would end up here at 0, and we're rising by 1 on this side. Again, if we subtract backwards, the slope there would also be 0. So we have a y-intercept of 0 for this train as well. So let's take a look at what they say about all this. We can compare the y-intercepts. At 0 hours, no distance has been covered, so both y-intercepts are the same at 0. And then we're going to compare the rates of change. The speed of the Japanese train is 140 miles per hour, which we did right away. And then we can use the table to find the speed of the Chinese train, which we came up with 217 miles per hour. So we can say that since 217 is greater than 140, the function representing the Chinese high-speed train has a greater rate of change than the function representing the Japanese high-speed train. Now let's take a look at letter B. If you ride each train for 5 hours, how far will you travel in each? Well, we have two different equations here. We have m equals 140 times h, and in this case our h is going to be 5, so it's 140 times 5. which is 700. That's represented right here. We can move over here and do the same thing with this. We had M equals 217H. So in this case, we're going to multiply 217 times 5, and 217 times 5 is 1,085 miles. So that's how far you would travel with the Japanese train and with the Chinese train. Please press pause and do letters B and C. All right, let's take a look at problem number 3. This is about financial literacy, something that's very important to everybody. Angela and Benjamin each have a monthly cell phone bill. Angela's monthly cell phone bill is represented by the function y equals 0.15x plus 49, where x represents the minutes and y represents the cost. Benjamin's monthly cost is shown in the graph. So first of all, let's take a look at what this means. Basically what this means is that Angela is paying 15 cents per minute, and she's paying a flat fee up front of $49 each month. Okay, so we can take a look at the graph for Benjamin, and first of all find out the slope. The slope would be the change in y over change in x. We'll go from this point to this point. So the change in y is 72 minus 60 over the change in x is 120 minus 0. So I'm just going to put 120 because subtracting 0 is kind of meaningless here. So we would have 12 over 120. 12 over 120 would be 0.10. And we can notice that we have a y-intercept of 60. So we would have, putting it in the same format as this, we would have y equals 0.10 x plus 60. Now let's take a look at what they tell us. A function for Angela's bill has a y-intercept of 49. We had that already. You can see from the graph that the function for Benjamin's bill has a y-intercept of 60. When we put that in our equation right here. So Benjamin has a greater initial cost. The rate of change for Angela's monthly bill is 15 cents per minute. Find the rate of change for Ben. We did that, 10 cents per minute. So the rate of change for Benjamin's bill is 10 cents a minute. Angela pays more per minute than Benjamin. What will be the monthly cost for Angela and Benjamin for 200 minutes? We had two different equations here. We have y equals 1500 x plus 49 for Angela, and for Benjamin we had y equals 1/10 x plus our intercept here of 60. So Angela's monthly cost is represented here, and at 200 minutes Angela will pay 0.15 times 200 plus the 49, and check it in the calculator. That's going to be 79. So basically all we're going to do is take our 200 minutes and place it here in this equation and here in this equation. Use the graph to find Benjamin's cost at 200 minutes. We could just do that, move over here to 200 minutes and read it up, and indeed we are exactly at $80. But because you can't always read these graphs, let's say to 50 cents or 25 cents or whatever, I would recommend that you also know how to do it like this, where you can put it into the equation. You can put 200 times 15 would be $30. $30 plus 49 would be $79 for our total here. Here we would put 200 times 10 cents would be $20 plus our $60. We would have a grand total that equals grand total of $80. All right, let's take a look at problem number 4. Again, financial literacy. Lorena's mother needs to rent a truck to move some furniture. The cost to rent a truck from the two different companies is shown in the table and graph. Which company should she use to rent the truck for 40 miles? Because it's going to make a difference depending on how many miles you rent for, which one is going to be the better deal. So the first thing we can do is find the cost of renting a truck from Ron's rental, by extending the table. After 40 miles, the cost will be $75 plus $25 or $100. So in other words, we notice that we're adding 25 in each cell, and we only need to go one more cell here, so we can just put 40, and we're going to be at $100 here. So this Ron's rental is going to be $100. Find the cost of renting a truck from Crosstown Motors by analyzing the graph. So the y-intercept of the graph is 30. The slope or the rate of change is 45 minus 35 over 30 minus 10. That's represented right here, or 5/10. The equation, we're going to write it over here so it's a little larger, equals 0.5x plus 30, where y represents the total cost and x is the input of the miles driven. It can be used to find the total cost of renting a truck for 40 miles. So we're going to put 40 miles in here. So basically we're talking about y equals 1/2 of 40, so that would be 20, plus 30. We have a $50 rental fee. For this one here would be 50, and this one here is 100. So Crosstown Movers would cost less for 40 miles.